This is a video, a bit longer video about me making this thing here. It's a little box, and it has switches and audio output and an antenna jack on the back, and if you turn it on, it says hi, and then starts playing radio, which is nice. This is in a really nice 3D printed case I made with OpenSCAD and a box maker plugin script thingy that I downloaded from Thingyverse. I think it's called the Ultimate Box Maker. And in the following video, I'm just going to talk over the design process for this whole thing. It's battery powered, but it can also be powered from a 5-volt supply over this jack. And it automatically charges the battery and such. And it's very nice. It works very nicely. This is actually intended for our kitchen, and we're going to put it there and listen to the radio every now and then. You can also plug it into a stereo if you want, to an external amplifier. So what I would like to talk about first is the circuit I used. Well, then I'll talk about the module, this little Chinese radio module I used, and then I'll probably talk about the battery or something. And the circuit I used is it's very simple. It has the power in here. Then it goes to a diode, Schottky diode in that case, because the battery is around 4 volts and the radio runs up to around 3 volts. So a 0.6 volt diode drop is really unacceptable. Also, there's a diode here and a diode here. And this goes down and joins up, and then the battery is going to. It's just the right way around. I always drive the wrong way around, but we'll see. This here is the battery, and what this does is, if power is supplied, I should join the radio. Radio is connected up here, like this. What this does is, if power is supplied through here, it will flow through here, not into the battery, but into the radio. And also, it will flow through here, through this resistor that limits charging current, down into the battery, and will trickle charge this. I'm going to use a nickel metal hydride battery. I have around 1 billion of those from old phones, cordless phones, and I got to get rid of them, and they work fairly nice. It's so easy to charge them. I mean, end of charge detection is a whole lot of mess, but it's easy to trickle charge them. And if the power is removed, what happens is the battery will, via this path, just power the radio. This is a very, very nice little circuit. I'm going to build a little printed circuit board for it, but you could definitely also do this on a piece of a strip board or something. So let's get right into the module and the build. This is the module I was just talking about, and here's the DC inputs and speaker outputs, as well as the antenna jack on the front. Well, the antenna solder pad, really. Also frequency knob and volume knob. And on the back there's 2 amplifiers. They sort of look like op amps, but I bet they aren't. Headphone jack, USB in for power. And also there's a mono to stereo jumper that I'll set later to mono. And also, interestingly enough, there's a UART port. You can probably interface the microcontroller from there. If supplied with power, the thing turns on and says a brief hi, and it's really messing with the camera there. Let me just, way better. So display is very, very bright, and as said, on the right is frequency knob. You can have some sort of auto mute thing where if it doesn't receive a station, it will just mute the audio output. I don't know what the LED on the bottom does. The left is the volume knob, and that's all about it actually. So the next thing I'll do is just design a little power supply for the battery and the radio. And I'll need some connectors first, where I can just supply input power and get the output power from. I usually use those Phoenix connectors, the footprint for them at least. I'm actually using some cheap ones from China, but they have the right footprint for that. And it's always a bit of, I have to scroll down a lot in Eagle. I use Eagle for almost all PCB design. I find it to work very well, and you can get it for free if you're a student. So actually, you can get it for free anyway, but if you're a student, you can actually get the professional version. So there I'm placing the footprint for the two connectors. So what I'll do next is I'll just grab some diodes and put them down. I explained how the circuit works in the first part of the video. It's actually quite interesting, and I got the general idea from actually the Art of Electronic book by Horowitz and the other guy. It's in the first chapter where they have a little circuit. It's actually exercise 112 or something, where you have to design a circuit that, when power is supplied, charges the battery, but when power is not supplied, the battery will power a clock in the example, and here it's a radio module, but it will work very well. So I'm putting down some through-hole diodes right now. The type doesn't really matter, I just chose about the right size. I will later decide to actually use SMD diodes, because those were the only small Schottky diodes I had. The only through-hole Schottky diodes I had were 4 amps, I think, so they're huge. And the next thing I'll do is just grab a random battery footprint. I think it's the one for 9-volt battery that I'm choosing here. And I'll just put that down as well. As I said, it doesn't really matter, because the battery I showed has cables on it anyway, so I'll just going to end up putting it somewhere. I just want to create some pads on the board about the right size. You could actually, this circuit is so simple, you could definitely do it on a piece of Vero board, a strip board or something. But I chose to design a PCB here just because it's a bit tidier and neater. I'm just connecting up the diodes here. The reason I chose, although not shown in the schematic, Schottky diodes, it was always the plan, is because the lower voltage drop. The radio module is supplied, well, when the battery is charged right up, it's around 4 volts, 4.5. But it goes down as the battery discharges to just around 3.3 volts. So if you have a 0.6 volt diode drop, that will definitely ruin your day. And there I'm putting down the charging resistor. In my case, this is about a kilo ohm, which works out to around 5 milliamps of charge current, which is fine for the battery. Might be a bit high for a trickle charger, but, well, if the battery doesn't have a long life, I'll just replace it. So there I'm just making the last of the connections. What I'm doing now is just a little precaution, because at the time when I was designing the circuit board, I wasn't sure if this mono to stereo jumper, if it really works and how it works, and So I just put a little circuit on here that could create a mono signal from a stereo one, because I definitely wanted to have only one speaker in the case. The problem with this circuit is I tried it with the radio module set to stereo and it doesn't work. It causes horrible glitches in the radio and all. And this is because the radio isn't meant to have a shared ground between the two audio outputs. Sometimes you can do that and sometimes you can't do it. I don't know when. But in this case, it definitely does not work. If anyone knows that, please tell me why this does not work. I mean, yeah, because it's probably not a floating output. But yeah, I wasn't sure about it, and I designed it the wrong way. And here I'm just replacing the diodes with some SMD diodes. As I said before, while I was designing this, I checked my part drawers, and I found that the only Schottky diodes I had were ridiculously huge. So I'm just going to grab an SMD one here and just replace them all. So this is the little circuit I just drew on a breadboard with a power supply connected up to it and the radio module and a 360 milliamp nickel metal hydride battery. And you can see that at the moment when the power supply is on, there's 30 milliamps flowing into the battery, which I'll reduce later. This is just a test with a smaller value resistor. And if I switch off the power now, you can see that now 39 milliamps are flowing out of the battery into the radio module and it's still running. So the circuit works perfectly. And I connect it up again. There we go. Thing is charging again. This is just a screen capture of me laying out the board, and I'm playing it in 3 times actual speed because I think there's not a lot of things that are more boring than watching someone lay out a board for 25 minutes. There's actually not much to say about here. On top there's the stereo to mono circuit that doesn't work at all. I didn't even populate that in the later PCB I made. And down is the little charger board, which I'm just arranging and mirroring the diodes so they're on the bottom side. I'm just going to connect everything up, and that's about it. The resistor footprints I chose here are a lot bigger than they need to be, just to have a bit of wiggle room in case I needed to use a bigger resistor or something. And I measured the size of the board before, so it would fit perfectly into the PCB standoffs I designed into the case that I 3D printed. So it's exactly a 5 centimeter by 5 centimeter PCB, which I also checked that the battery will fit on it nicely. I'll just glue it to the top side, and you can see that later. So here I'm just making some last minute adjustments and I'm just about done. So let's just go over the things real quick that I need to assemble this radio. It's that FM radio module, it's one small nickel metal hydride battery. This one is a 320 milliamp hour battery with 3 cells, which are 2/3 length. 2 RCA connectors, a USB charging port, I use these on all my projects. Switch and antenna connector, just use a banana plug here. Small speaker, small baffle for the speaker. It fits in here like this, which I 3D printed. And then also the case also 3D printed. It has the cutouts and I drilled some holes for this on the backside. So the only thing that's missing from the parts is the circuit board. This top here is the stereo to mono converter. What I'm going to do now is just solder up this board real quick. I'm there flooding it with flux, which you shouldn't do, but my flux pen did go a bit wonky. This is 3 times the speed, because same with the board layout, it's incredibly boring to watch someone solder a board for, 10 minutes or so. And first I'm putting on the diodes, and I'm just there off camera searching for my tweezers. And look at that, I found them. I could do reflow soldering here, but with 3 components, why bother, really? It's just so much quicker and easier to just dab a bit of solder on them. So now the diodes are all done and soldered. Sorry for leaning my head into the camera there every now and then. I didn't realize at the time that I was doing that. And still more soldering on the diodes. So now I'm just dremeling some holes into the board. I also muted the audio because it would literally kill headphone users. And also people that just turn down the volume because this is incredibly loud on the original video. Also, I'm doing this voiceover on the whole thing because at the time I was doing this, I had my wisdom teeth removed, and so I couldn't talk properly. So I'm just now, a week later, voiceovering over the whole thing. And there I put in the charging resistor, just soldered it up real quick. And now the last thing to do is just to put the battery in, which I'm going to put on the top, and I'm going to snot it down with a bit of hot snot. And here now it's just a very, very, very condensed video of me assembling the thing. The original video files are over 30 minutes long. I usually have them at 10 times the speed you'd actually watch them, and I also muted the audio. And that's it. Whole thing assembled. Switch it on. Says hi. Play some radio. Can also mute it and switch it to stereo only mode, where it just supplies an amplifier, not is actually stereo.